Hello, and welcome to the Chesapeake Node.js user group, CNUG. This is a presentation, our first presentation on Node.js, and the title of the presentation is Getting Started. So here's our URL and a shameless plug for our group, so look us up online. Links to the presentation will be available on the Meetup site. What we're going to cover today is installing Node.js, a little background about it, its runtime, some of the software installation things, code editors, verifying your installation, how to use Node.js once you've installed it, the command line interface, the interactive console, debugging mode, and some other aspects. So let's get to it. What is Node.js? Node.js is a server-side or a back-end engine to execute JavaScript. Initially, JavaScript only ran in a browser. So this is JavaScript running outside of a browser. Node.js runs on V8, which is Google's high-performance JavaScript engine, same one used in the browser, or in the Chrome browser at least. V8 is written in C++. There's a link to some more information about it. V8, and therefore Node.js, implements ECMA script specified by the ECMA 262 specification. Node.js is supported by version. There's lots of different features out there and different runtimes, and here's a URL, Node Green, to give you some information about the different versions and what's supported. Node.js as a runtime is designed for single threading. The main event listeners that are going to drive your program are single threaded. You don't want your particular program waiting for anything too long. Asynchronous calls are good. Because of that, this also makes Node.js perfect for deploying in containers. Any events within Node.js are handed off to the underlying operating system, in this case Linux. So Node.js programs should run pretty quickly. And they should, to take advantage of that, use non-blocking calls. The background worker threads driven by the OS will handle the I/O. The underlying Linux kernel is multi-threaded, so there's no reason for the Node.js engine to be that way. Node.js is pretty fast. Node.js has something called the event processing loop, and it goes through various steps in a loop that goes through them sequentially and then loops back to the beginning. That's illustrated here. So it says, hey, is there any things that timed out that I should do? Nope. Okay. Are there any pending callbacks? Nope. Okay. Is there any internal processing I need to do? That's the idle and prepare phase. Nope. Okay. Are there any new I/O events I should handle? Nope. Okay. Are there any phase events I should handle? Are there any callbacks that I should handle? There's examples to the left, and then it repeats the process, and it's optimized so it'll only spend so much time in any one phase, keeps going through those. So all the pieces of work that need to get dispatched in Node.js get dispatched because Node.js keeps going through this loop. And when your process can't do something, it's going to be in one of the phases in this event processing loop waiting for some event to happen. Let's get down to getting Node.js up and running. So step one is go get the software. Here it is, nodejs.org, the download site. It's supported on a number of platforms, Windows, Mac, Linux, various Unix flavors. So go ahead and download it. There's two versions, long-term support and current. Long-term support is designed to be stable, but won't have the latest and greatest features. Current has the latest and greatest features, but things may break as the next release comes out and feature gets put in that changes something. So if you want stability, you probably want to download the long-term support. If it's a dev environment and you're just playing with it and you want the latest and greatest stuff, go with the current release, 10.7. Windows, I didn't even put any screenshots here. It's just a Windows install. launch the installer, keep clicking next, hitting the enter key. It installs really easily, even on Windows 10. One thing to make sure is you want to make sure that NPM is selected on your install, and like a lot of Windows installs, you're going to have to reboot your computer. I didn't do the install instructions for every platform. Installation's pretty straightforward. You can get more information on that on the Node website. I thought that most developers are probably going to be running Node locally on their laptops. In addition to the Node.js runtime for your Node program, you may want an editor or an integrated development environment to develop your JavaScript programs in. There's lots of them out there: Atom, Eclipse, Visual Studio. I personally have Eclipse on my machine, but that's because a lot of products I use Eclipse. That's what will be demoed here: Visual Studio and Atom and others. They all work fine. Notepad++ will work fine too. Doesn't need something real fancy. Node.js couldn't be much simpler to run. We're going to see this. You launch a DOS command window, and you just say Node. And if you want to do NPM to download software, NPM does not stand for Node Package Manager, by the way. And if you go to the NPM website, it's pretty cute. They'll have made-up names that vary all the time for what NPM stands for. So it doesn't have any meaning, but a lot of people call it the Node Package Manager, but it doesn't officially stand for that. There's a Windows bat file to launch the command window and to execute a JavaScript program and to generate JavaScript from that. I think actually I'm going to switch screens right here, and I have a little shortcut on my desk. Here's the properties. You can see this is the Node.js command line interface. Here it is. Node variables.bat is the file. If I simply click that, up comes something that looks suspiciously like a DOS window and behaves like a DOS window, a command window, because that's what it is. This is just set up for you, and then set your path and everything to make sure that Node is there. Obviously I can't type here. There we're running version Node 10.8. And if we actually wanted to execute some JavaScript, we could just say Node and go into interactive mode, and then say we'll just set a variable A equal to value 1. Exit, Control-C again, just Node in interactive mode. So just a DOS window, launching it's no problem whatsoever. There's a number of options that can be used when you launch it. So the formal syntax is the formal syntax is the Node command, any options, the program name you want to execute. If it has a file extension of .js, you do not need to include that file extension. It will be assumed if there is no extension. And then there's a double dash here, and then any arguments you want to pass into this Node program. These are not arguments being passed to Node. These are arguments being passed to the script you're executing. These options up here, check, evaluate an expression, excuse me again, ask for some help, enter interactive debugging mode, execute a program in debugging mode, print some JavaScript data, the expression results, load a specific module, display the version. We just did that a bit ago. Again, I emphasize this at the end of the command, that -- following the script. Those are arguments being passed to your script, not being passed to the node command itself. So if you write a script that expects some arguments, here's how you invoke it, and here's how you pass that script those arguments. There's also a number of environment variables that you can set that affect the execution of Node. Node path is a colon-separated list of directories to search for scripts if you want to load scripts. If you want to suppress some warning messages, there's no warning there. There's a number of settings to control your SSL, TLS processing, where to find your key store, etc. You can also, this is the -P option, Node-P or Node print, about a specific JSON object. So let's scroll back over here. If we said Node-P console, it would display information about the console object or about the JSON object or about the math object. You can see some of these, when it's printing them out, are going to be less interesting than others. On some of these, you might want to execute a specific command to iterate through all of the properties of, for instance, JSON or math. But the -P is a useful command line option to display information about some things if you want to see it. You might try that for OS. Look at the various OS settings you have. Here's an example of printing the console object. Node also has a mode that they call REPL, R-E-P-L. It stands for Read, Evaluate, Print loop, and it's just read an input instruction, evaluate it, print the results of it, and loop back and do that process again, REPL. And it's an interactive command line argument. We saw a glimpse of that earlier. So REPL can be invoked either by just typing node with no parameters or node-interactive, or node-I. To get out of it, you saw this earlier, Control-C twice or Control-D once. There's a special syntax in there that underline represents the results of the previous expression. Every expression in JavaScript, of course, returns an object that has some properties. We can enter debugging mode. We launch debugging mode saying node inspect and then the program name. If we didn't have that inspect keyword in there and just said node program name, we would launch that program script and it would run till the end. So as an example here, clear my screen. We have a couple of sample programs here. If I say node example 3, this is a program that runs through. It supports the sample program to demonstrate some of the stuff in another presentation, our next presentation coming up, the one on JavaScript. And it just executes it straight out. If we wanted to, in that program, put a breakpoint and stop at that breakpoint, we could use the inspect operation and run that program from Node, and then Node would stop at that breakpoint. So giving us an interactive debugging tool. Very useful. And to create a breakpoint, all you do is say debugger, semicolon, in your JavaScript, and then when you run with the inspect keyword, node inspect my program, it'll stop at these debuggers. We're going to see more about debugging later, but we can look at various values, all kinds of stuff. Breakpoints can be set in the script. Breakpoints can be set during debugging. Set breakpoint command here. Variables may be watched. You can say watch and it will display the properties of that object you're watching. You can put a list of things to watch. Commands can be executed. It's not as good as a full-blown integrated development environment, an IDE, but you know, it's a pretty nice tool right off the shelf. You can do a lot with it. Debug commands, here's some. There's a help. If you want to see all the debug commands, there's a lot. You can manage breakpoints, list all of them with the breakpoints command, set breakpoints at a line number, add a function, beginning of a function, add a specific line in the script. You can clear breakpoints, CB, clear breakpoint there. You can, once you're in debugging mode, you can resume the execution of the script with a C. That will go to the next breakpoint. You can execute the next expression. You can step into or out of a function, pause the execution, restart the script, number of commands. There's informational commands. The backtrace will show you a little bit of the execution history. You can execute a command there that's not in your script by saying exec and giving it an expression right here, and it'll return the results of that expression. You can list some of the code around where your breakpoint is, so you can see whatever this number is. Let's say it's 10. You could see the 10 preceding and 10 following statements, so you get some idea where you are in the program. REPL here enters the REPL mode we discussed earlier. Scripts lists all the scripts that are loaded, unwatch and watch, add expressions to the watch list. And if you type in watchers, it says this is all the things I'm watching and this is all the values. So kind of displays all the memory you're looking at. There's some tools that go along with Node. Lints, in general, is a code analysis tool. There are several JavaScript linters: JS-lint, JS-hint, ES-lint. There's references here to all of them. You may find them useful. What they do is go through your program and suggest ways to improve it if there are errors in it, or if there's code that doesn't meet the lint specifications or standards, it will flag it. So multiple linters out there. Some are very configurable. You can configure them to your taste, some not so much. Find one that you like, use it. JS-hint is pretty popular. Really difficult here. npm install global JS-hint. Just that command. That's all it takes to install it. Assuming you have npm, and during your installations instructions, we ask that you verify that you are installing npm. Here we just verified it. We're running version 6.3 of npm. So all we have to do to download something is execute that command. This says npm, install some software. Install it globally. That's in all of my projects rather than just this current directory. And here's what I want you to install, JS-hint. To get lint information about a script, that's really hard. JS-hint space script name. Not too hard. There's a file in the directory called JS-hint RC. And you may need to modify that to support some things, to tell it which version of VCMA script that you want it to lint against, and customize it. So there's a lot of customization, a lot of stuff about that on the web. Here's some official documentation sites for the JavaScript API, Node command, Node debugger. This is a pretty good reference if you're new to the debugger. Questions? We can take those offline. I'll end the recording and we can go into free-form conversation mode. Thank you very much.